Class 12 Relations and Functions. Exercise 1.1. In the last video, I have solved first heading, first question. In this video, I will solve first heading, second question. So we have to check whether the given relation is reflexive, symmetric and transitive. So here the relation is given on the set of natural numbers and it is defined on the relation xy such that y is equals to x plus 5 and x is less than 4. So first let us write down what is the set given to us. N is equal to 1, 2, 3. This is an infinite set, right? And how the relation is defined on this set, xy such that y is equals to x plus 5 and x is less than 4. So they have given this in set builder form. We can write all the elements of R. So let us see how to write them. First, what is the property they have given? That y is equals to x plus 5 and x is strictly less than 4. So what are the elements we have to take? That has to be less than 4, but it has to be from the natural numbers. So only we get 3 elements, 1, 2 and 3, right? So if we give input x is equals to 1, so 1 plus 5 will get 6. So the first element is 1, 6. 1, 6. Now if we give input 2, 2 plus 5 is equals to 7. So the next ordered pair is 2, 7. So here we are going to get 2, 7. If we give 3 as the input, 3 plus 5 is equals to 8. So the third ordered pair is 3, 8. So we got one more element, that is 3, 8. So these are the elements in a relation. Now let us check if R is reflexive. So what is the condition for R to be reflexive? If A belongs to R, that is A must be related to itself for all A belonging to, what is the set they have defined here is N. So if this condition satisfies, then it is reflexive. So let us see if every element is related to itself. Here in R, 1, 1 does not belongs to R, 2, 2 does not belongs to R. If you keep on going, any element is not related to itself. So clearly we can say that R is not reflexive, right, for all A belonging to natural numbers. There is no such mirror images which is related to itself. Now let us check if R is symmetric. So what is the condition for R to be symmetric? If AB belongs to the relation, then BA will also belong to the relation. So let us see if this happens. Here 1, 6 belongs to R, 1, 6 belongs to R, but 6, 1 does not belong to R. So if you take 2, 7 belonging to R, but 7, 2 does not belong to R. So clearly AB belongs to R, but BA does not belong to R. So therefore we can conclude that R is not symmetric. Okay. The next is to check whether R is transitive. So this is actually in the textbook they have given it is transitive. Actually it is transitive. So let us try to understand the logic behind it. See here, I have taken 3 examples, 3 relations R1, R2 and R3 to give a very clear understanding how or when the relation becomes transitive. So what is the meaning for a relation to be transitive? That if AB belongs to R and BC belongs to R, then AC belongs to R. That means if this both happens, or if this both exist, this must and should exist. Okay, if this both exist, both the couples should exist, then definitely this has to be there. Okay, so let us see whether these three relations in the different cases are there, whether they are transitive or not. So the third relation, I'll take the third relation first. So AB, BC, AC. So the couple exists here, AB, BC. So if this exists, this also exists. That means it is transitive. Okay. Let us go for the second relation, AB and BC. The couple exists here, but this does not exist. If this exists, this has to exist. So though the elements are there, though the connected related pairs are there, but AC does not belong to this relation. So therefore this is not transitive. Okay. Now the third relation, ABCD. Just check whether a connected relation is there. A is related to B, but we don't have any element where B is related to some other element. Okay, we have CD, but we don't have any ordered pair or element where D is related to another element, right? So this thing is missing here. This part is missing here. Okay. If this part is missing, clearly we can say that this does not exist. If this does not exist, it doesn't mean that this should also not exist. Right. So this part is missing here. So therefore it is clear that there is nobody to violate the transitive property. So we can clearly say that this is transitive. Okay. I'll explain once again. If this happens, if this exists, this must exist. If this does not exist, then this can exist or does not exist, will not violate the transitive property. So there is nobody to violate transitive property. So the basic condition is this one. If this does not happen, then how can you enter in checking, or how can you understand whether it is transitive? Because this BC is missing here. So that's why we say that this is a transitive relation. Okay. So now coming to this case, here R is transitive because there is no AB BC. Okay, there is no AB BC to prove that what if A is related to B, that is if AB and BC belongs to R, then AC belongs to R. Okay. So what is the final conclusion? The given relation R is neither reflexive nor symmetric, but it is transitive. I'll explain this once again. Okay. If this exists, this must exist. If this does not exist, there is no point, or there is no importance of checking if this exists or not. So there is no counter example to disprove that it is transitive or not.